Evaluating these logarithms in the end are not extraordinarily difficult because with a little bit of exploration you could see that each one of these numbers is actually a power of the base of the logarithm, which makes it a little easier, and it'd be even easier yet once we discuss a few properties later on in this chapter. But for the time being, we're going to use some of the rules that you just saw in the notes to answer these questions. Now for A, the log base 2 of 32, what you really just want to do is think of this as an equation set equal to x, because that's what you're looking for. You're looking for the value of what this is. Using this idea that these are equivalent statements, and more importantly, we're going to go in this direction, starting with the logarithm, heading back to the exponential statement. The log base a of b equals x is the same thing as a to the x equals b. Notice where the various symbols are, a, b, and x. So when I turn this into an equivalent exponential statement, the 2 is going to be the base of the exponential, the x is going to be the exponent, and 32 is going to be the value on the right hand side. So now this problem essentially becomes what this logarithm is asking you to find, which is the power of 2 that would give you 32. And this is where you'd have to explore, depending on how well you know your powers of 2 and other bases for other situations, you can find out that 32 is the same thing as 2 to the 5th power. So you know that 2 to the x power equals 2 to the 5th. That means that x equals 5. So log base 2 of 32 is 5. For the log of 1 million, first you have to realize that, again, we're going to set this equal to x, but a log without an exponential base being given is assumed to be log base 10. There's going to be another type of logarithm we learn about a little bit later. It has a different base that's understood, but that has a different symbolism to it. But anytime you don't see a base next to the word log, you assume it's base 10. And so this is saying log base 10 of 1 million equals x. Transforming it into its equivalent exponential statement, you would have 10 to the x power equaling 1 million. Powers of 10 are easier because of the fact that the number of zeros that you have in this is going to be the power of 10 it is. So there's 6 zeros here. So 1 million is the same thing as 10 to the 6th power. And since 10 to the x equals 10 to the 6th, x is going to equal 6. So the log of 1 million is 6, because it's basically just asking you the power of 10 that gives you 1 million. This one's asking you the power of 6 that gives you 1,679,616. So again, setting this equal to x and making it its equivalent exponential statement, 6 to the x power would equal this 1,679,616. So you got to figure out what power of 6 this is. And if you, with a little bit of exploration, you can figure out that is 6 to the 8th power, which means x equals 8. So the log base 6 of 1,679,616 is 8. As you proceed through this, you're going to get to situations that are a little bit more complicated, because the number you have to the right may not be an integer power of the base of the logarithm, and that's where things get a little bit trickier.